Number 12 is a little bit tricky in that it requires a little bit of work and manipulation before we can make a u substitution that's going to allow us to integrate. And if you notice, the original integrand is kind of reminiscent of arctan's derivative, or the derivative of inverse tangent. And so what we want is we want something like 1 over 1 plus u squared. Now let's see what we can do to make that happen. For starters, we can try to turn this 2 into that 1, right? Obviously without violating any rules of algebra. So one way I might be able to do that is factoring a 2 out in the denominator. So 2 divided by 2 is going to leave me with 1. 4x squared divided by 2 is going to leave me with 2x squared. And now if I pull that 2 out in front of the integral, I'm going to have 1/2 times the integral of 1 over 1 plus 2x squared dx. And now this is fairly close, right? Because you've got 1 plus 2x squared. And if we choose u such that u squared is equal to 2x squared, then we'll be in good shape. Now the choice of u that does that for us is root 2 times x, right? Because squaring that gives you 2 times x squared. So now we want to figure out what to do with dx. To do that, we take the derivative of u with respect to x, and derivative of x is 1, so that leaves us with root 2. We want to solve for dx, or at least see what the appropriate substitution is. So I get du is equal to root 2 dx, bringing the root 2 to the other side as a 1 over root 2. I end up with 1 over root 2 du is equal to dx, right? So now I know what to replace dx with. Okay, and at this point we're ready to substitute and get an integral in terms of u. Okay, so the 1 over half out front we're not going to touch. In the denominator we're going to replace the 2x squared with u squared, and then the dx we're going to replace with 1 over root 2 du. So that's going to give us 1/2 integral of 1 over 1 plus u squared times 1 over root 2 du. Okay, so we have an integral entirely in terms of u. Now it's just a matter of simplifying and taking the antiderivative. So I'm going to bring the 1 over root 2 out front just to simplify things. So now I've got 1 over 2 root 2 times the integral of 1 over 1 plus u squared du. And now this is precisely the derivative of arctan of u, or tan inverse of u. So when you take the antiderivative, constant out front stays. We'll write this as arctan, or you can write it as tan inverse if you prefer, plus a constant. And so for our final answer, we get 1 over 2 root 2 arctan of our choice of u, again, was root 2x, plus our constant c.